Physics Unlock, your gateway to mastering physics fundamentals. Today we are diving into the versatile world of vectors, unit vector, position vector, null vector, and free vectors. Get ready to discover how scalars multiply with vectors and unravel the mystery of vector resolution. Join me, Hajra Mughal, for an engaging and easy to flow exploration of vectors operations. So let's get started. So what is unit vector? So a unit vector is a dimensionless vector with a magnitude of 1, serving as a directional reference for other vectors. Its primary purpose is to represent the direction without altering the magnitude of other vectors. Now, what is meant by this? Because unit vector, unit means it has a unit magnitude, so this concept is used to represent the direction of any other vector, right, without altering the magnitude of any other vector, right? So let's suppose if I have any vector A, so the vector A is represented with the arrowhead, but the unit vector which is used to represent the direction of this vector is represented by the cap over this vector, and it will be drawn in the same direction as the given vector. Now we know that the concept of the vector is that it's a product of magnitude and the direction. So how we are going to write the vector? It is written with the product of magnitude, and for the direction we are going to use the a cap, which is a unit vector, because unit vector is used to represent the direction of any other vector. So this is the representation, or you can say a symbol to represent the direction, and in simple words we can say it's a unit vector, right? So if I wanted to calculate how to find a unit vector, then it's a ratio. It's a ratio of the vector along with its own magnitude. And magnitude, the representation of a magnitude can be represented in two ways. Like in mod, you can write the alphabet in a mod, or simply you will write a bold alphabet. Both are the representation to represent a magnitude. So when you divide a vector with its own magnitude, then we get the unit vector. So a unit vector is obtained by dividing vector by its own magnitude. Some important unit vectors. In Cartesian coordinate system, we use three special unit vectors to show direction in 3D space. I cap points right along the x-axis, j cap points up along the y-axis, and k cap points forward along the z-axis. These unit vectors do not change the magnitude or the dimension of anything. They only indicate the directions along x, y, and z axis.
Null vector is basically a vector having zero magnitude and have some arbitrary direction. Is called a null vector, and it is usually represented by this zero along with the arrowhead. Basically, it is just a mathematical concept which help us to define negative of a vector. It has no magnitude, it has no direction, but still it is called vector because we get it after adding, subtracting, or multiplying two vectors. For example, let's say there are two vectors A and B which are equal in magnitude but opposite in direction. Then the sum of these two vectors will be equal to 0 vector. Now we can add them by the help of head to tail rule. Thus, if we place the tail of B over the head of A, then third side of the triangle vanishes, and we call it as 0 vector. We can write it with the help of this equation. Let's suppose we have some vector A, and if we are adding that vector A with the same vector but opposite in direction, so we will get a 0 vector, which is also known as null vector. Then we have a concept of free vectors, a vector which is used to displace parallel to itself to represent, here you can see this is x-axis and y-axis, and let's suppose I have some vector A, and if I want this vector A to be drawn over here. So I can displace this vector A parallel to itself without changing its magnitude and direction. So this is called free vectors, and this concept is usually used in different types of derivations. Position vector. So in order to understand the position vector, let's suppose we have x-axis, x, O is origin, and y-axis, and I have some point which I have represented here. This. So if I want to locate this point, that in which direction this point is, so I will make a line and I connect from the O to P, and let's suppose this point P have numbers from 2 to 3. Now what is meant by this 2 and 3? It means that 2 unit on x-axis and 3 unit on y-axis. 2 unit x-axis, it means that 2 I cap. Why I am using I cap? I cap is the unit vector to represent along x-axis, and I will make 3 unit line along y-axis. So basically what I am doing, I have connect this point from O to P, so I am giving it direction from O to P. This, let's say this vector OP is equivalent to R. OP is equivalent to R, which is known as position vector. Now what is meant by this? A vector with the help of which we can locate the position of a point with respect to some fixed point. Fixed point means origin. If I want to locate this point with respect to some fixed point, so what I need to do, I need to make a vector from origin means fixed point to that point, and by the help of this point I can calculate this value along x-axis and y-axis, and I can make an equation like here. You can see that position vector is equals to xi cap plus y j cap. So position vector is nothing, it's a vector which is used to represent, which is used to locate the position of. Multiplication of a vector by a scalar. It means that I want to multiply a vector by a scalar quantity. So consider some scalar means a number which is denoted by K and a vector denoted by A. As you can see in this diagram, this is a vector A having some magnitude and the direction in between x and y axis, and this vector A is in xy plane. Now we want to multiply scalar with a vector, so now the magnitude of vector A depends on this scalar and also its direction. So let's suppose if K is equals to 0, means that that number is 0. So when you multiply that number 0 with this vector, you will have answer 0. And let's suppose if you are multiplying some scalar which is greater than 0, it means that it's a positive number. Anything which is greater than 0 is positive and lesser than 0 is negative. So obviously I have written plus k, it means that it is some positive number. It can be plus 2, it can be plus 3, plus 5, plus 100, anything. So when you multiply it, you will get a positive vector and its direction will be in a positive axis. And if you have some number which is less than 0, it means that it is a negative scalar, and when you multiply it with a vector, you will get negative of a vector. What is meant by this? Look at here. Let's suppose that scalar is 2. So when you multiply this vector A with 2, so its magnitude will be increased twice. Its magnitude will be multiplied by 2. and the direction remains same because it's a positive number, and we know that this xy coordinate shows it is a positive coordinate. But here you can see if I multiply it with the -2 number, it means that that scalar is less than 0. So the magnitude will be increased by -2, but the direction is also reverse. Now it is in a negative xy plane. It means that x dash and y dash. We know that we have a 4 coordinates, 1, 2, 3, 4. So first coordinate have positive x-axis and y-axis, and third coordinate have negative x and y-axis. So this is how we multiply a scalar by a vector. Just remember these 3 rules. When you have a positive scalar, so that magnitude of that vector will be increased by that number and direction will remain same. But if you have a negative scalar, so magnitude will be increased by that number but in a reverse. Resolution of vectors. Students, in this topic, you will learn that how vectors can be resolved into its components. First of all, what is meant by components and how we can resolve? Look at here. So each vectors may be broken down or resolved into 2 components, which are x component, which is horizontal component, y component means vertical component. As you can see from this diagram, if I want to resolve this vector into its component, first of all tell me this vector, in which direction this vector is available. It is in x direction or it is in y direction. So you cannot say that this vector in x direction or y direction. It is the combination of xy direction. So whenever a vector is the combination of xy, so we resolve it into x component and its y component. It is important. Now here you can see this vector is completely in x direction. So there is no need to resolve this vector into its component because it is in x direction already. And this vector is in xy plane. This vector is in xy plane. This vector is in xy plane. Every vector is in xy plane except this one. So whenever the vector is in xy plane, so we need to resolve into x.
Okay, so let's talk about the resolution of a vector. This is the process of splitting a vector into 2 or more components. To demonstrate this, let us consider an x-axis and a y-axis. X-axis is represented with x, o, x dash, and y-axis is represented with y, o, y dash. Now let's consider a vector A that makes an angle theta A with the x-axis, right? Notice that the vector A isn't aligned with either the x-axis or y-axis, so we wanted to break out or break it down into x and y components. So to do this, we draw two perpendicular lines from the tip of a vector A from the point P, one to the x-axis and one to the y-axis. These intersection points represents the x and y components, which we call ax and ay. But if I want this ax component to be here on the x-axis, then I'll use the definition of a free vector, and this is the component ax on the x-axis. So what I'm going to do, this is the component ay, similar. But if I want to do a resolution of a vector, then they must be added in a way that it represents the head to tail rule. So you can see from the diagram that ax component when added in ay component, then the resultant vector is a, right? So you can see the head to tail rule. It follows the head to tail rule. So if I wanted to write the equation, the final equation, then when you add the ax vector into an ay vector, then you will get this resultant vector a. And these ax and ay are known as rectangular components of vector a. Why they are called rectangular vectors? Because they both vectors are making 90 degrees. Rectangular means the vectors are making 90 degrees with each other. And if I wanted to write this equation in a magnitude and a unit vector form, then a vector can be represented with a magnitude and a unit vector. So we know that I cap is the unit vector that is in the direction of x, and j cap is the unit vector that is in the direction of y. So this is the equation that is written in a vector form, and this is the equation that is written in a vector into unit vector, or you can say a direction form. Components represented in terms of a vector A. So to express the x component, which is ax of vector A in terms of A itself, or a vector ay in terms of A, then we utilize the previously drawn triangle OPQ. Observing the relationship between ax and A, we can recognize that the base and hypotenuse are involved. So applying the trigonometric principle, you can see that specifically the cosine function which relates the base to the hypotenuse. So we can derive the formula considering the triangle OPQ, the cosine function is base over hypotenuse. So from figure you can see that the base is ax and the hypotenuse is A. So taking A on other side, the value of ax will become ax equals to A cos theta. This equation represents the x component of vector A in terms of vector A, magnitude of vector A, and the angle theta. Similarly, to represent the AY vector, you can see the AY vector which is perpendicular and the A vector which is hypotenuse. So these two sides are involved, perpendicular and hypotenuse. So we can use perpendicular over hypotenuse sine theta. So sine theta is AY over A, and if I wanted to write AY in terms of A, then it is AY equals to A sine theta. So we have derived the formula of AX and AY in terms of A. So substituting these two equations, equation 2 and equation 3 in the previous equation 1, so we can write A cos theta I cap plus A sine theta j cap. Previously, the equation was AX I cap and AY j cap.
Magnitude of vector A. What is the magnitude of vector A? We will consider the same triangle OPQ, and we know that OPQ, whenever we have a right angle triangle, we can use Pythagoras theorem. And what is Pythagoras theorem? Hypotenuse square is equals to base square plus perpendicular square. And if I take root on both sides, so this square will be cancelled with this root, but this side will remain same. From this triangle OPQ, you can see that this A vector is hypotenuse, this AY is perpendicular, and AX is base. So my equation will become hypotenuse is A. I can write it as simple A, or if I want to represent magnitude, so it can also be represented by two lines which is known as mod of A. And base is AX square, perpendicular is AY square. So if I know the AX and AY from last equation, which is AX equivalent to A cos theta and AY equivalent to A sin theta. So when I calculate AX and AY and I will substitute here, so I can get magnitude of A. Direction of vector A. We know that vector A is a vector. So vector is the combination of magnitude and direction. So we have calculated the formula for the magnitude, which is mod of A equals to under root AX square plus AY square. If I know the components AX and AY, so I can easily calculate the magnitude of A. Now how we can calculate the direction? We know that the triangle, we will consider the same triangle OPQ. We have used two trigonometric ratios, sine and cos, in order to find AX and AY. Now only a single trigonometric is remaining, which is tangent theta, which is the combination of both trigonometry, sine and cos. So I will, in order to find direction, we will always use tangent theta, which is equivalent to perpendicular upon base. So perpendicular is AY and base is AX. So if I want to find theta, so tan inverse, tan will be move towards the right side, so tan inverse AY upon AX. If I know the value of AY and if I know the value of AX, so I can easily calculate this theta, which represents the direction of vector A. Theta is basically theta A. Okay, if I want to write this vector A in 3 dimension, so the formula will become, the magnitude of A vector will be calculated by this formula. The formula which we have studied for 2 dimension, ax square plus ay square plus az square under root equals to mod of A.
That's all for today. Thank you for tuning in to the Physics Unlocked. If you enjoy this video, please consider subscribing to my channel for more engaging physics content. Your support means a lot. Don't forget to hit the like button, share your thoughts in the comments, and spread the knowledge by sharing this video with your friends and family.